How many of you have built a machine learning or deep learning model before? Have you ever gotten really good accuracy, like 99%? That's awesome. Would you trust it to stop this truck? Even with your 90% accuracy, 99? The lives and the people in the car, the driver, all of the other people around you or them depend on your model. Are you feeling the pressure? Do you think we're ready for that? Would you trust your model to accurately classify someone who committed a crime and not send maybe the wrong person to jail? There are a lot of ways that AI could hurt people's lives, not just physical injury. Models like text, search, facial recognition have been found to be biased, and they're also used in ways that can lead to really serious life consequences, as discussed in the film documentary Coded Bias. So these are some of the ways that our lives can be impacted by our work and the things that we need to think through. Do you trust your model with your life? Anyone's life? So that's what we're going to talk about today. I'm Heather GORR. My background is in physics and machine learning for my PhD. And I'm a product manager for the MathWorks, and we make MATLAB and Simulink, the platforms. And we have many, many users that are trying to integrate AI models into these type of systems. So we'll share some insights with you. AI impacts our lives. We know this. Many of you have already built machine and deep learning models for these applications. We're even hearing all about it at the conference. But as AI impacts our lives just more and more, we really have a lot to think about before we want to release it into the world. So that's what we'll talk about, really kind of putting that research and your model to work. What do we need to think about in a real system? We'll talk about the strategies and differences sort of in that phase. We really want to consider the people. It's really the most important thing. We'll talk about that throughout. Then also the model itself, how easy it is to understand, interpret the results. And then of course, testing and pulling everything together before we actually deploy. So we'll start by thinking about the people. We'll actually talk about this throughout. That's one thing to always keep in mind is who is it for, who's involved, who's building it, who's using it, the people. These are really complicated systems. This is just an example sketch for one of the vehicle systems. There's simulations, testing, deployment, and it's really just one part of that full system. So, you can imagine there are a number of people that also work on the system, right? So you have, data scientists or engineers building the models. You have your hardware engineer integrating it, or system architects, things like that. And everyone has a different background and skill in this case. It's not even just tech. Sometimes there are lawyers, managers, certification folks, and users, of course. Ideally, everybody needs to be on the same page and know at least some level what's going on in the different parts of the system. And of course, the more diverse, the better. With these big kind of projects, you want to see all angles, everyone really brings value. This is kind of the nature of explainability or interpretability too. Everyone involved needs to understand at some level, even the users. Deep learning, machine learning can seem mysterious, but there are some basic answers and explanations needed from both the humans and the machine, right? And you can see that these are important decisions and questions, right? So we want to make sure also at the same time our model is fair and equitable. And so a lot of that has to do with what we give the machine, what information we give. And so it needs to learn given the data, just like a human. And so this is why we all want to check our algorithms, data sets, scoring mechanisms, and make sure we're teaching our machines properly. So the people are really important to think about. Again, that's why we started there first. So let's talk a little bit more about this model stuff, this explainability. We'll talk about a little bit more. We don't have a ton of time to dig in, but we'll share some strategies for the model approach and then some resources for you to learn more. First, you want to consider how complicated a model that you need in the first place. Some models are more interpretable by nature. Decision tree, for example, it's sort of known for documenting decisions, although maybe not easiest to understand right away. There are, again, ways to kind of sort through or get through the tree. You could prune it, make it a little bit easier to understand. But, you maybe could just use F equals MA. So, maybe there's an even simpler strategy that people can understand and that would work for you. Now, I know, it's very tempting to go straight to deep learning and get your cool networks and aggregations and all kinds of awesome math. But that also can make it hard to understand. So this is an example of common models ranked by accuracy and interpretability. And then, of course, don't forget regular math equations if appropriate. So there's a lot more to learn on this page. There are pretty good techniques. There's a lot of research in this area as well. Techniques like LIME, GradCam, occlusion sensitivity, and these will help you understand how the predictions were made and which features of your data set contribute to the prediction the most. And so that's really helpful in kind of going back and really understanding, what's going on with that system. Of course, beyond the model itself, we need to really look at the data and the information we're giving to the machine, which is really fundamental to the model. So a lot of groupings and classes are often imbalanced, and this can be some of the nature of the challenges in a lot of these examples, really just not enough diversity in the training sets one way or another. So one strategy is to supplement the data. You could sample differently, really kind of think through that case. Of course, in the more mechanical examples, vehicle, for example, most days you're driving well. You're not slamming on the brakes, hopefully, or crashing into something. But we don't want to also crash more often just so we can get more data for the model. We can simulate the data to get sort of those bad situations without causing any harm. And this is an example of a lane detection. This is using MATLAB and Simulink, like I mentioned before, which is really common for this kind of application, where you really need to get a really realistic data generation, right? So really as similar to life as possible. So we see this a lot for maintenance and prototyping these engineering designs, since again we don't want to have very expensive fails, right? And regardless of how good your model is or what we've done to get there, you're probably going to have errors, you're going to have some edge cases, and you really just learn a lot during this model exploration process. So it's really important to document, be transparent, share as much as you can. Again, even a lot of cases, you actually need to document everything for certifications or legal reasons. Remember the audience, there's a lot of people involved. So, again, something we often think about with MATLAB. Here, this is an example of a live script, just capturing results, code, equations, kind of whatever we want to document and communicate. So as I mentioned, there's a lot more research and active work in this area. And there are possibilities to use supplemental data sets and learn a lot more about explainability and bias in these techniques. So now let's think a little bit more past the model. So I think really rigorous testing is an understatement. I maybe should have thought of something even more dramatic. But really the edge cases could mean someone's life. So it's so important to test and document as much as possible all throughout the process. We also, of course, we want to assess the model. We can use cross-validation, resampling, standard accuracy measures, but it's also really important to test in the operational environment, on the device or in as close to that condition as possible. This is an example of testing a model in web server production for a streaming calculation. And so it's nice because we provide apps for creating the environment, and it just makes it a lot easier to debug and test in sort of this mini server. So this is a really good technique, kind of taking that next step for integration. Other things that you might hear about in the testing space, like test-driven development, can be really, really helpful. This is where you start writing tests from the very beginning. And it's important here because, the system's kind of complicated like this. You want to sit down with everybody, capture the requirements, and really just kind of start building your tests and applications from there. And so that'll also really help in the model development. It's important, but it's not that hard, especially, if it sounds scary, if it's not something that you've done before. Again, this is something that we really focus on with MATLAB, trying to embrace and enable all skill levels and backgrounds to buy into this world. So you can copy and paste whatever you use to call your code, add an assert, and you got a test. So it's really helpful because, it's a lot lower barrier to entry. You don't have to take a ton of time and, make up some big thing, just copy and paste. And of course, you have a lot more capabilities, and that also helps collaborate, because you could have people writing functions, classes, even in other languages, and then just add them into a suite and run it all together. So we see that really helping a lot with collaboration. And that's actually our last topic, kind of discussing how do we pull all this together, and actually get it into the system and integrate our model. Oftentimes, I mentioned this a bunch, the model's incorporated into a larger system, much, much larger in many cases, and you're often deploying onto a device like a GPU, FPGA, cloud, something like that. And so, again, this is something that we want to think about. It could add complications, if you just kind of start diving into the math and the model, and then, you realize, oh, there's only this much data coming into the system. So that's something to really think about before you get started. There's also a lot of handoffs. We mentioned there's a lot of people involved. Maybe I'm building the model. I need to hand it off to somebody else to be able to deploy it into C++, Python, or on a device or whatever. So again, this is really common with MATLAB and Simulink. So we provide apps to help with this. And that way you can package everything up and just really enable the next person to use your work easily, even if you don't understand quite as much about what's going on in the next phase. And that really helps out a lot. So, of course, this final phase, you get tons of errors and failures and everyone's miserable. Just kidding. Hopefully not. You really want to start together and stay together the whole time. It's not this final collaboration thing like it sounds. You want to be on the same page. You can use source control, other software collaboration practices. This is another example of MATLAB. There's a MATLAB project that helps with managing things like path, directory, source control. Even if you're not experienced, they can really help walk through it. Again, always in the spirit of enabling the other people around you and yourself, and keeping everyone in mind as we work together and build these really important systems. So it's been a pretty short amount of time. We talked about several aspects of bringing our models into reality. Remember, we want to keep in mind the people. We've said that a lot, but these are ultimately systems for people by people. We want to keep our models simple and explainable, kind of in that spirit. Test as much as possible, as best as possible in the system. And then whatever you can do to collaborate during the process and just ease any of those pains in the final integrations. So hopefully you've found this useful. Maybe you'll be more mindful whenever you're developing your models, thinking through. Not sure if you're ready to trust it with your life or the lives of others yet, but we know now more to consider in our next steps. So thanks for joining me and allowing me to share, and I hope we can keep this conversation going. Thanks.